So in number 1, what do we have to do there? Add like terms, right? They're like terms if the variables have the same power. So 3m cubed, you can combine that with negative 2m cubed, and you just get m cubed. The m doesn't change, just the coefficient. Negative 3m squared and negative 1m squared be negative 4m squared. Positive 4 and positive 6 is positive 10. Does it matter what order you write those terms in? If I put like 10 plus m cubed minus 4m squared? No. You can add in any order. So if you did switch your order around, that's no big deal. Number 2, what's the first step? Okay. If I take my 3 through, that gives me 24p squared minus 15p. What do I need to distribute on this one? Negative 5. So that's negative 15p squared plus 10p minus 20. So there's that minus. Make sure you run your negative through. Add like terms. 24p squared and negative 15p squared. Gives you 9p squared. Negative 15 and positive 10 gives us negative 5p minus 20. Would it be okay if you had like 9p squared plus negative 5p? Is that the same thing? Yeah. So whether you put the minus or plus a negative, it doesn't matter. Are there questions on that one? Number 3, what do we have to do? FOIL. So 4r times 7r is 28r squared. Outside be 8r. Inside negative 7r. Last, negative 1 times 2 is negative 2. Add like terms. So 28r squared plus r minus 2. Number 4. If there is a square, can I just distribute that to each piece? No. What do we have to do? FOIL. If these things were multiplied inside, if it was only one term, we could bring the square in. But a square means there's 2 of them. It's a minus 6b times a minus 6b, so we have to FOIL that. So we get a squared minus 6ab minus 6ab. Negative 6b times negative 6b is positive 36b squared. Add like terms. So we have a squared minus 12ab plus 36b squared. And number 5. What's the first step here? Distribute. So if I take my negative y through, that's negative y to the third. Negative y times negative 4 is positive 4y. 6y squared times 2y, remember just add the exponents, so that's 12y to the third minus 18y squared. Okay, we need to combine like terms. Negative y cubed and 12y squared to be 11, or excuse me, and 12y cubed to be 11y cubed. Minus 18y squared plus 4y. Again, you could have those in a different order, that's no big deal. How'd you guys do? Did okay? Do we need more practice with this type of thing, or do we remember? What I want to do, take a second, I asked you guys to get your syllabus signed, so if you could get that bottom, I just need the bottom part, so just tear that off, and I will collect those, and then we will start the next one. Okay, so the first thing I want to talk about in factoring. The very first step, no matter what problem you are given, what's the first thing you look for? Do you guys remember? Remember greatest common factor? We always have to check for that first. So that's going to be the first thing I talk about. We're just going to factor out the greatest common factor to begin. All right, so greatest common factor. If I am looking at these, that's just saying with these three terms, what do they have in common? What could I pull out of all of those? 2. When you pull it out, remember, it doesn't just go away. We put it out in front, then we put our parenthesis, and then what's left? X squared minus 2x plus 4. Okay. Our directions on these were just to look for the greatest common factor, so we're done for that problem. B. What can I pull out of this one? 6a squared. Okay, if you take something out entirely, what do you put there? A 1. It doesn't just disappear, you put a 1 minus. Okay, 18 divided by 6 is 3. You had 4 a's, you took out 2 of them. So there are 2 left. That is a square, it just doesn't look like it. All right. A couple more. And guys, if I'm ever going too fast, just tell me. I'll slow down. Sometimes I get excited and just speed up. So. All right. What can we pull out on this?
7.
7. Okay, then we look at the variables. For the x's, you have to take out the smallest exponent. So for my x's, I have a 3, a 2, and a 2. So we could take out x squared. Y's, I have y squared, y cubed, and y squared, so we take out y squared. Okay. 14 divided by 7 is 2. I took out 2 of the x's, so I have 1 left. I took out all those y's, so I can just drop that. Minus 28 divided by 7 is 4. I took out all the x's and I took out 2 y's, so there is 1 y remaining. Plus 21 divided by 7 is 3. I took out the x's and the y's. Last one like this. Okay, looking at the coefficients, we have 3 terms here. Remember, the terms are separated by the addition and subtraction. So what can I take out of every term? 2. What else do they all have? X minus 2. Okay. 24 divided by 2 is 12. I took out one of the x minus 2, so that leaves me x minus 2 squared. Minus 16 divided by 2 is 8. I took out one x minus 2, so there is 1 remaining. 6 divided by 2 would be 3, and I only had one x minus 2, so it's those brackets, remember, just act like parentheses. You could put another parenthesis there. I usually, if I already have one set of parentheses, I use brackets, so it's easier to tell what's what. Do you guys remember doing this? Kind of, sort of. The next thing I want to look at is difference of squares. So with factoring, always your first step is your GCF, greatest common factor. We do that first. Every problem checks it. Then your strategy is based on the number of terms. If you have 2 terms, we check for difference of squares. So let's look at some. If I gave you x squared minus 4. So still check every time. Is there a greatest common factor in that? No, they don't have anything in common. Then it's 2 terms, so we look difference of squares. Do you guys remember how that? It's basically going to factor into 2 identical parentheses with 1 difference. One has a plus, the other has a minus. So x squared would break into x and x. 4 would break to 2 and 2. So it's difference of squares. It has to be a subtraction to work. And both of these have to be perfect squares. So you guys see if you can do this one for me. Is there a greatest common factor? No. Is it difference of squares? We have subtraction. Are both of those things perfect squares? Yes. Okay, so one of these positive and one negative. And then you're essentially just doing the square root of those pieces. The square root of 16x squared would be 4x. Square root of 1 is 1. So 4x plus 1, 4x minus 1. And order doesn't matter. If you put the minus in the first parenthesis and the plus in the second, that's fine. Let's do a couple more. Difference of squares. Are those both perfect squares? We have a subtraction. What's the square root of x to the 4th? Right. Or if you have 4 x's, you put 2 in each parenthesis. Square root of 16 is 4. Okay. We are not done. Why? This one is a plus, so we can't do anything with it. This one's a subtraction, but aren't both of these still perfect squares? So we can break it down again. So the x squared plus 4 just stays, it doesn't factor. But I can do difference of squares again on this one. So x squared would break into an x, and 4 would give me 2 and 2. So always check to make sure it is completely factored, that it won't go any further. Okay. Greatest common factor, do we have one? No. Can I do difference of squares? They're both perfect squares, but it's not a difference, it's a sum. What do we put if something can't be factored? Line. So you can only factor it if you have that subtraction. If it's addition, all we could do is look for a greatest common factor. How much of this is at least looking familiar? You know you've seen it before. What do you do when you have 3 terms? You remember? Trinomials? Box method. Okay, so that's the last piece of factoring we're going to talk about today. We're going to do some box method problems, and then tomorrow we'll just be practicing all of this some more. But I want to start out with some box method problems here, where the leading coefficient is 1, where we just have a 1x squared. So you guys remember the box method? You do your box every time. There is a shortcut. Did Mrs. Keller ever talk about the shortcut with you? Like sometimes you don't have to do the full box. You guys ever talk about that? Maybe. Let me show you and then you'll tell me if you've seen it. Okay. So this is a problem that we could actually factor without drawing the box. You can certainly draw the box, but just to save us some time, as long as you have a 1x squared, you can do this shortcut. We don't do the box. I'm going to go straight to my two parentheses. Okay, if you have an x squared, what do you think goes in each of those? One of the x's. So we have an x. And then, just like in the box, you ask yourself what multiplies to 8 and what adds to 6. So I just need what two numbers multiply to positive 8 and add to positive 6. What would that be? 2 and 4. Okay. So you could have, if you had done the full box with that, it certainly works. You put your x squared here and your 8 here. So those multiply to 8. Add to 6. And you get the same answer, but as long as it's a 1x squared, you can just jump straight to the two parentheses. You don't have to go through the whole process of drawing the box. So let's practice that a little bit. Okay, so it's a 1x squared. That means I can go straight to my parentheses. We put an x in each. Then I need two numbers that multiply to give you the constant and add to give you the middle term. So multiply to a negative 18 and add to a positive 3. Positive 6 and negative 3. And if you flip those, put them in the other parentheses, that's fine. Okay, let me put up a couple for you guys to try on your own. Okay. So multiply to a positive 40 and add to a positive 13. That would be 8 and 5. How do you check yourself on a factoring problem? Multiply it back out and see if you get what you started with. D. Multiply to a negative 14. So if it's going to multiply to a negative, we know we need a positive and a negative. And add to positive 5, or excuse me, negative 5. Negative 7 times 2 is negative 14. Negative 7 plus 2 is negative 5. All right. So far, so good? Let's look at this one. What do you notice about that? we have a 2 there instead of our 1. Okay, first step to factoring is always look for greatest common factor. Can I pull something out of all those? They don't all have an x, but we have 2, 12, and 18, so we could take out the 2. $12 divided by 2, 6. 18 divided by 2 is 9. Am I done? No, because now I can do box method with that. So x squared breaks into x and x. Two numbers that multiply to 9 and add to 6. That's 3 plus 3. What's another way you could write that? Good. So if you have the same thing twice, you can write it twice or write it squared. I don't care. What would I do on this? Can I pull anything out? No. Can I do my shortcut box method? No. So it's a trinomial. We have to do the full box method in this case. If it's the x squared has a coefficient, then you have to do the box. Remember, the squared term, the first number goes in this first box. Your constant goes in the last box here. Now I need two numbers. If I multiply these, they have to multiply to give me a 9, and they have to add to our middle term here, which was -6. So what would multiply to +9 and add to -6? Then, if you remember, we factor each column and each row. If the first number is negative, you pull out a negative. Otherwise, it's positive. So 9x squared and -3x, this is positive, so I will take out a positive 3x. -3x and 1, since the first one is negative, we take out -1. 9x squared and -3x, we would take out 3x. -3x and 1, take out -1. So this is 3x minus 1 times 3x minus 1, or we could write that as 3x minus 1 squared. I think I'm going to go ahead and stop here for today. I want to do some more practice with those, but I want to give you guys a little bit of class time to work. So, you know what? I posted a handout in Classroom, but not all of you have Chromebooks. So, I will have to put that on the board so you can copy problems down. I'll put that on the board here in just a second. Because we didn't get quite through everything, we're not going to do all of the handout yet. I just want you to try problems 1 through 12. And I will put these up on the board in case you don't have your Chromebook. So the handout, if you have your Chromebook, there's a handout on Classroom, do 1 through